couple more math problems here. I got some homework over the weekend, and I want to just kind of fill this out.
You going to verbalize them, or are you going to send them to me?
I can verbalize them.
Okay.
It's only 6 problems. I want to go through them all.
Okay.
Hold on. Let me just grab a pencil really quick.
Yeah, let me turn my volume up just a little bit. I'm having a little hard time hearing you.
Okay.
There you go. That's perfect on my end.
Hold on. I need to find a pencil really fast. Just give
Okay.
me 1 second. I'll be right back.
Always try to have a pencil and a calculator.
Alright.
I should say pencil, piece of paper, and a calculator.
Yeah.
That's what you want for our sessions.
Alright, well, got this right here. So it says solve the equation using the quadratic formula. Round your solutions to the nearest tenth if necessary.
Okay.
And so first one is x squared minus 10x minus 11 equals 0.
Do you know the quadratic formula?
Kind of. I could tell you what it is if I saw it, but I think it's something plus or minus the square root of minus 4ac over 2a or something like that.
You're close. The only part you're missing is the minus b.
Okay.
And unfortunately, you cannot get away without memorizing this. If you want to get through high school math, you have to know this. You're going to be asked this on the SAT, on the ACT, on every math test. Now, I understand that they have a song that they teach some students. I unfortunately don't know what it is. So, but you had the important part, which was the plus or minus the square root of b squared minus 4ac all over 2a. The only thing you needed was the first part. Now, notice something. You can always divide fractions up this way. So that first part is minus b over 2a, which happens to be the formula for the vertex of the, or the x-coordinate of the vertex. In other words, if I wanted the vertex of this quadratic and I wanted its x-coordinate, it's equal to that. And sometimes that's the easiest way to solve for the vertex.
Okay.
It just is. If I said, what's the vertex of that? You would say 10 over 2. That's the x-coordinate of the vertex, is 5.
Okay.
Okay? So these are both really good to memorize. What the x-coordinate of the vertex is, and that actually has its own name. It's called the discriminant. And a lot of times, the very first step is figuring out whether that discriminant is positive or negative.
Okay.
Now, for this particular quadratic, tell me what A, B, and C are, because that's what you need to know to fill in.
Would a be x squared, b would be 10, and then c would be negative 11? Oh, no, negative 10, I mean.
Remember that A, B, and C are always numbers. They're never variables, ever.
Okay.
They are the coefficients of the variable.
So negative 10, negative 11, and 0?
A is 1.
Oh, okay.
B is minus 10, and C is minus 11.
Okay.
Okay, so let's plug that in. What do we have? X equals, what's minus B?
Minus b, oh, that'd be positive 10.
Plus or minus, fill in the rest of it for me. What's B squared minus 4AC? And do it one step at a time. Don't, I mean, you can square B if you want. It's easy enough to square B, but.
I'll just square it. It'll be 100 minus 4AC. So hold on. So it'll be a.
Now this this is where this is the easiest place to make a mistake, is in the 4AC.
Mm-hmm.
It just is. Okay? So I have a very specific technique that I use for solving this. I always do that as my next step.
Okay.
And the reason is notice what we're looking at. I'm looking at a negative sign right there, and I'm looking at a negative sign right there. It's very easy to make a mistake and think both of those are subtraction. Well, they're not. And if you do the 4AC first, what do you get?
If you do the 4AC first, you get so 4 times 1 is 4 times -11, so it'd be -44, or no?
So, no, you're right. Here's what I want you to write, though. It's minus -44. In other words, the easiest mistake to make is getting the sign wrong.
Okay.
Okay. What's 100 minus a -44?
144.
Okay, so now we have 10 plus or minus the square root of 144, all divided by 2. What's that turn into? What two solutions? First of all, what's the square root of 144?
12.
Now, give me the two answers.
10 plus or minus 12, so it'll be 22 and -2.
22 divided by 2
11.
and -2 divided by 2.
-1.
So 11 and -1. Okay?
Oh, so that's the answer?
Those are the answers for x. In other words, what this plus or minus means is that one answer uses the plus, the other answer uses the minus.
Okay.
Okay? Now, let's go back and notice that they specifically ask you to do this using the quadratic formula, and that's fine. But notice that there actually was a quite a bit easier way to do it by just factoring. Factor this for me. What are the signs? Both signs. They're both opposite.
Yeah.
You cannot produce a -11 without having opposite signs. And now you're looking for factors, and let me back up a second. Because the quadratic produced two integer answers, that always tells you it could have been factored.
Okay.
Okay? In other words, there was an easier way to do this. If I got whole numbers here, then it must have been factorable. And it is. It's factors of 11 that subtract to the number 10. Well, that would be 11 and 1.
Okay.
Now, if you solve that, either that has to be 0 and that has to be 0. So that produces x equals -1, x equals 11. Those two answers I would have gotten in 10 seconds. The same two answers we get using the quadratic formula, as it always will be.
Okay.
The difference is that you frequently get quadratics where you cannot factor them. Turn that into a 12 and instead of an 11, now I can't factor it.
Yeah.
Now I have to use the quadratic formula. And the quadratic formula is going to give me answers like 1 plus or minus square root of 3, all divided by 2. In other words, this is the typical kind of answers you get from the quadratic formula, where you have an irrational number as part of your answer. They gave you one that was actually more easily solved by factoring, but they ask you to solve it using the quadratic. I like that because it shows you that the quadratic always works 100% of the time, whereas factoring only works part of the time.
Okay.
And only when the answers for x are whole integer numbers.
All right, cool.
All right, what else you got?
I got negative x minus 1 equals negative 2x squared.
All right, what are we looking at here? What is this?
I don't know.
Kind of an equation. Is it linear? Is it quadratic? Is it cubic? What is it?
I'd say it's probably exponential.
Right there. That says it's quadratic.
Okay.
Okay? Y equals 3x plus 2. That's linear. That is a straight line right over there.
Yeah.
This is a quadratic, meaning it's either a parabola that goes like that or it's a parabola that goes like that.
Okay.
When I have a quadratic that has an x squared term, also an x term, also a number without an x, then the typical way to solve it is by putting everything on one side and putting 0 on the other.
Okay.
So let's do that. Where am I going to put my x squared term? On the right side or the left side?
To put your x squared term on the since it's already on the right side, will you put it on the left? Or?
I would put it on the left because I want a positive coefficient.
Okay.
It is
That's right.
hard to factor when you have negative coefficients on your x squared term. So the determining factor as to where you're going to put it is I want this number to be positive. That means I have to move it over to the other side. Okay?
Okay.
Now, what was over there is fine. What's left over on the right side is 0. Okay? Now, this is a little bit harder to factor than, this is not an elementary factoring problem. This is at least a second degree, but not really that hard. It's worth giving it a shot. We'll know in one step whether we can factor it or not. If we can't factor it, we will apply the quadratic formula. What's the
Okay.
first step of factoring?
Would that be you'd divide it or?
Split up the x squared. How do they split up? In other words, you're always starting with that.
Okay. So if you're starting with that, I'm still not.
Split it up. So whatever here multiplied by here is equal to 2x squared. In other words, what you're doing is foiling in reverse.
Okay.
So split up the 2x squared. What must it be?
I 1/2 or something like that.
Well, how about 2x times x? 2x.
2x.
In other words, that's going to be the very first term after you FOIL it, and that's equal to 2x squared. That has to be true. When I say split up the x squareds, that's what I mean.
Okay.
I mean, split it up such that when you multiply them back together again, they're this. Now, theoretically, I could have made it 2x squared and 1, but you never do that. You always split up the x's. Always.
Okay.
Okay? Second step, determine the signs. Both of them at the same time.
Since it's negative, would they have to be opposites?
They have to be opposite. Now, with this scenario, there's opposite, but it turns out that it could be minus over there and plus over there, and you have to consider both of them. Whenever the coefficient of the x term is different, then you have to consider both possibilities. That's why this is a little bit harder of a factoring problem. Okay? The easy part is there's only two factors of 1, and that's 1 and 1. So I don't have a lot of options here. I can put a 1 there and a 1 there, see if that works. And if it doesn't, then I can put the one with the negative sign and the other one with the positive sign. This is totally trial and error. When you get a second degree quadratic, it's not second degree because of the 2, it's a second degree because it's not 1. If it's 1, they're easy. You either factor them or use the quadratic formula. If it's a number greater than 1, in this case 2, then it's a trial and error process. Okay? Now, to determine whether this is the correct solution, the only thing I really need to check is the inside and the outside terms. I use what I call as my double smiley face. What's the product of the inside terms?
So that would just be 1x, so just x, right?
Let's put the plus there and let's put the 1 there. What's the product of the outside terms?
2x, 1. So I don't know if that'd be 3x or just 2x plus 1.
Hold on, you're multiplying, you're not adding. So you're multiplying
So
negative 1.
just 2x. Oh, so negative 2x.
So that's negative 2x.
Yeah, negative 2x or positive 2x because it's plus or minus, right?
No.
Oh.
We're not considering the plus at the moment. We're only considering the negative.
All right.
I didn't mean to mislead you by writing this as plus or minus. This is not the same kind of plus or minus as we have when we deal with the quadratic formula.
Okay.
Okay? This case, it's either plus 1 times minus 1 or minus 1 times plus 1, or else it's not factorable. Well,
Okay.
the way you check is to check the sum of the inside and the outside terms, and that's why I call it my double smiley face. Okay, now add those two terms together. What do you get?
Add those, the 1x and the negative 2x.
Uh-huh.
You just get negative 1x.
Which is what we've got.
Okay.
That means we've got the right answer. So the answer is 2x plus 1 times x minus 1 equals 0. Now, we don't quite have the answer yet. What we have is the factors. So if we're solving for x, what is x going to be equal to? There's always two solutions. You always set that one equal to 0 and you set that one equal to 0. So what do you get when you do both of those?
So if you set both the 2x to 0 and the x to, so
just start on the left and work your way right. So set 2x plus 1 equals 0. Solve that.
so that would be 2x equals negative 1.
Keep going.
If you subtracted both sides, and then the x minus 1 equals 0. So
hold on.
That would just be x equals positive 1.
All right. Now what happened is you tried to do two steps in your head and you got the wrong answer. So here's the first step you did. You subtracted 1 from both sides. But then you thought it was x minus 1 equals 0. So not writing it down made a difference. Now we're going to divide both sides by 2. That's one of my answers for x.
Oh, okay. Yeah, I see that.
Now I'm going to set that equal to 0. X minus 1 equals 0, which means x equals 1. That's my other answer for x. So most of the times when you have a quadratic, you do end up with two distinct answers.
Okay.
Okay? So you're always looking for two answers. Now, every now and then, you'll only get one answer, but it's actually the same answer twice. And you have to be kind of on the lookout for that because that'll happen every now and then. But 95% of the time, you're going to have two different answers for x. And that's why the quadratic formula reads like this. That's two different answers. The plus and the minus create two answers, not one.
All right.
The only time that this plus minus does not come into play is when that is precisely equal to 0.
All right.
Then the answer is only minus b over 2a. Okay, but any time that b squared minus 4ac is not 0, then you're always going to have two answers for x
Okay,
whenever
I
you
get
have
that.
a quadratic. And it's very important to recognize when you're looking at a quadratic.
Okay.
In fact, polynomials are the next subject you're really tackling. Okay? What's this?
Uh,
What's that called?
Polynomial.
Well, that's correct, but it's a certain type of polynomial. It's a cubic.
Oh, okay.
In other
Cubic.
words, you line up the exponents so that they're always in order,
All
and
right.
whatever the highest degree is, that's what it is. If you had x to the fourth plus 1, that is a quartic. Quartic. Q-U-A-R, quartic, like that. Like a quart of milk. There's 4 quarts to a gallon.
Okay.
Okay? So, over the next couple of years, you're going to be dealing with cubics and quartics, but this whole year, you're going to be dealing with quadratics and sometimes linear.
Okay.
Okay? And those are key. It's key to distinguish between the two. Okay? What else you
Okay.
got?
Makes sense. It's probably going to be the last one. It's going to be x squared plus 3 equals 5x.
What are we looking at here in terms of polynomials?
That just be a binomial.
Linear? Is it quadratic? Is it cubic?
Oh,
Is it quartic?
that's quadratic, I think.
Okay, so what do you do with quadratics? Whenever you have an x squared term, and you also have an x term, and you also have a number, there's one thing you always want to do with that quadratic.
I'm not sure.
You put everything on one side and leave 0 on the other. It's a key,
Okay.
it's a key step. Which side am I going to put everything on? The left or the right?
Left side.
Okay, so do it.
So, there'll be x squared equals 5x minus
Hold on,
3.
hold on,
Oh,
hold on.
oh
If
no,
I'm
sorry.
putting everything on the left side, I'm moving that 5x over to the left
Yeah.
and put it in order. Get used to
Yeah.
writing your polynomials in order of degree.
Okay, hold on. Just gotta think about this real quick. So if you move
All
that
I
over
have
to the
to
left,
do to get rid of that 5x from the right side.
subtract it, and
Okay?
then subtract it on both sides, so then you'd
That's
have a
what I
negative
end
on the
up
left
with.
side.
I still
Minus
have
5x
3.
plus 3 equals 0.
There you go. Okay? Now,
Okay.
it doesn't take a whole lot of attempts to realize that you cannot factor this.
Yeah.
X minus 3 times x minus 1 does not produce this middle term. Okay? I mean, once you get pretty decent at factoring, it doesn't take long to realize that. So, this problem, since I cannot factor it, I've got to use the quadratic formula. What's quadratic formula again?
That's a negative b plus or minus the square root of negative b
No,
minus
this b
4ac.
squared. Hold on, that first term is b
Oh
squared
yeah, b squared. My bad.
minus 4a.
Minus 4ac all
Remember
over
what
2a.
that is, because that actually has its own name. That's the discriminant. And I don't mean the square root. I meant b squared minus 4ac is called the discriminant. And there's a reason it has its own name, which we don't need to get into now. But it makes it easier to memorize if you think
Okay.
of that as being its own thing. In other words, b squared minus 4ac, that's called the discriminant. Okay?
Okay.
So it's minus b plus or minus the square root of the discriminant, all divided by 2a. Tell me what a, b, and c are.
So hold on, let me see over here. So a would be 1, and then b would be negative 5, and c would be 3.
Okay, now let's plug it in. So I got x equals, plug it in for me.
X equals, oh, okay, so -1 plus or
Hold
minus,
on, it's negative b.
oh, negative b, so 5, positive 5, plus or minus 25, minus, let's see, so that'll be
Just substitute here. Don't try to do
okay,
any math.
4, 1, and then
Yeah,
3.
a is 1, that's 3. Now do your math. Well, first of
All
all,
over 2.
put the
Yeah,
denominator in there. Okay, now
yeah.
what does this radical become?
Uh, like the 4AC.
Yeah, you can do that. That's what I recommend everybody do without the negative sign, because whatever
Okay.
4AC is going to be subtracted from 25.
So it's 12, I think.
Okay, so 25 minus 12 is 13.
Yeah.
So we get an answer that's 5 plus or minus root 13, which can't be simplified. That's a prime number.
All over 2.
And
So
there,
would that be it?
that's your answer. That's actually two answers. It's 5 plus root 13 all over 2. And the other answer is 5 minus root 13 all over 2.
Okay,
Now,
cool.
if they ask you to round that off to the nearest, how many decimal point places?
The nearest tenth.
You're going to have to do that in your calculator. In other
Okay.
words, your calculator is capable of rounding that off. But
Okay.
just to be clear here, this is the most perfect answer. And by that I mean that is a precise answer. That is not rounded.
Okay.
If I turn that into a decimal, I necessarily have to round it off. I can round it off to one place or a million places, but I'm still rounding it off. If you
Okay.
want to give a precise answer, and that's what will happen as you go forward in math, is they will quit this, round it off to a decimal, and they will have you give your answers in this format, where you leave it as a radical, because that's an irrational number, root 13. So if I change that to a decimal, I am necessarily rounding it off, which you'd rather not do in math. You'd rather leave your answers as perfect answers.
Okay, cool.
Okay, but it depends on
Yeah,
the
that makes sense.
instructions and what level of algebra you're at and stuff. You're still at a level of algebra where they're going to probably ask you to round it off to a decimal. Just put that into your calculator and come up with a decimal, round it off to the nearest tenth. But as you get into Algebra 2 and precalculus, they'll stop asking you to do that.
Yeah.
Okay?
Okay. Cool.
So you have a good rest of your weekend. I will talk to you next Tuesday at 6.
Yeah.
Okay? So we're still on for Tuesdays and Thursdays at 6.
Yeah.
Okay, sounds good. Talk to you then.
All right. See ya.
Bye-bye.